Okay. So great to see people again. Really excited for today with the boot camp. Lots to look forward to. That's good. I note that someone had a little charger up here that perhaps was left in the room yesterday. If anyone's looking for that, it'll be up here in the front. So I'm going to begin today, as I am wont, with some reflection on yesterday, as well as with some announcements. And maybe I'll get the announcements out of the way first. Per my email that I sent last night, I'm happy to report that the deficit was resolved with respect to the posting of talks. And so, to the best of my knowledge, the complete set of lecture recordings, set of Java tutorial slides, and set of example models that we built together in class is now up on the Google Drive site. So those models which we puzzled through yesterday are now up there and available for download. Some of you may have your Drive syncing with that, sort of staying in sync with it, in which case you may get those automatically. So those are up there. They're there for reference, and please let me know of any big quality problems. There's at least one or two where we know the audio died during it, and I've tried audio. So just be aware there are some which are known, but if you don't see that marked, let us know so that we can mark it accordingly. We don't want to be putting content out there which is not. So that was a little bit of announcement. I guess another announcement is for anyone who's going to be taking a TA aside this morning and going out and tooling on projects, two things. First of all, the reminder that there's a set of small project meeting rooms. So if I were to walk through this wall, there'd be meeting rooms over there on the right-hand side, two of them, I think, and over here on the left-hand side. These are small meeting rooms, ideal for groups from 2 to 10 or so, although there's one that's smaller. And I'd encourage you to take advantage of them. I know a lot of projects have been meeting here in this room, and that's also great. Just be aware that you can work in solitude or in a quiet over there very easily. There's projectors and other things which there may not be for the small groups here to make use of. So if you want to show your model to project mates, you can do so over in the small rooms. Okay, so that's one announcement related to those pursuing project work. The other announcement is, especially if you're going to be taking off for some time this morning, today's lunch is going to be here, and as I understand it, it's going to be catered from outside, and the reps that were here yesterday took the day. Is that right? So it's going to be wraps. Yeah. Okay. Thanks. And you got veg and non-veg wraps. Yeah. Okay. Great. So we'll be doing that here, and two of the TAs will be presenting on some work they've been doing and trying to get the materials from boot camps like this up, not in just a fragmented way where you have video, but where you have the videos linked in with other relevant content, such as slides, such as the example models, such as relevant exercises, etc. So you can kind of go from one to the other fairly easily. And also working to subdivide those videos into easily digestible pieces on particular topics. So I'd like to thank Camelpreet in the back there, who's been doing the very hard yeoman's work of taking the content I'm delivering during this boot camp and dividing it up into these nuggets, these little pieces. And we're going to try to benefit from that by then putting them online in an interlinked way and a link back to the whole video. But it takes a lot of effort, a lot of attention, particularly with a speaker such as I. So I appreciate Kamalpreet's efforts in that regard. So those are a few announcements. Any logistical questions or announcements from those here? Okay. So we're going to be continuing today. in sort of our model. We're going to have project time this afternoon, and we're going to start off the day with a bunch of hands-on exercises and sort of further contributions to understand how modeling is conducted. But I stand before you at a watershed moment, a moment of significance, and it's a moment of pride, I hope, on the part of you folks, because we have now come, in the course of the past several days, through all the major elements of the AnyLogic modeling vocabulary, all these pieces out of which we build models, sort of little bits of functionality, things like events, states and state charts and the transitions between them, things like populations, and defining agent classes, statistics, all these other little pieces that we've been learning, capped yesterday by mobility. Those are key elements to kind of understand how the sort of little bits of things you weave together to build up these models. And we've now completed basically our survey of those. Those are little details which I've left out, things like dynamic events, dynamic parameters, which some of you in Java tutorials might see. But we've really completed sort of the systematic tour of a bunch of these things. And you're to be congratulated for your endurance, for your stamina. And I hope we'll all recognize we've come a long distance. I'm really impressed with the group and how far it's come. Yesterday, we concluded our little tour of those with our discussion of mobility. And we started with a very stylized model, which, despite its winged forms, it didn't really aspire to represent any particular context. And we saw how we could capture mobility of agents within spaces. I talked a little bit about the two types of spaces that AnyLogic supports, and continuous spaces, which include both a GIS form, a form that knows about latitude and longitude, knows about bearing in a GIS sense, in a compass sense, on the one hand, and sort of a more abstract continuous space on the other. So that's continuous space. Agents, you don't have to worry about them overlapping. They can be precisely positioned at any level of reasonable precision. By contrast, there was a discrete space where we had a bunch of cells, a grid of cells, and only 0 or 1 agents can be in any one cell, and agents would move around, such as betweenst cells. So we have these spaces, and then we have mobility in those spaces. In the discrete space, the mobility was, by its nature, discrete. They hopped from cell to cell to cell, most commonly to empty cells, because they can't go into an occupied cell. And I gave a little shelling segregation model, to which I pointed you there. And there's a built-in one in AnyLogic that's also in discrete time. But in continuous space, we saw that how we could define movement using a set of common operations, things like a move to operation, a jump to. Anyone remember the difference in move to and jump to? Yeah, exactly. Move to is a slow progression. It's a little bit of a misnomer, the word move to, because it says basically start movement towards. And that movement proceeds according to someone's velocity. And sliders aside, we can adjust that velocity in AnyLogic, and some agents will go faster, some will go slower. Some will go at a rate of a sloth, and some like a bat out of hell. So we could set velocity, and that will allow them to move towards their destination, to some target, and we tell them the target. And by contrast, a jump to instantaneously teleports someone to somewhere. Were it only so, especially for our colleagues in LA. So you could just teleport there. And we saw that there were additional pieces of information we could get by calling someone's get X. If we had an agent, we could ask it. If we had a reference to an agent, A, we could ask A.getX. And we get their current X location or their current Y location. And I'm not talking about it here, but for those investigating bats and perhaps for those investigating chimps and various types of aerial fowl, there's also a Z direction that may be of interest to people. So there's X, Y, Z. It actually does capture movement in three-dimensional space. And there's some very compelling videos and visuals associated with this that you can capture in your AnyLogic models to depict three-dimensional structures. We're not touching on that here, and we didn't yesterday. But be aware that it is there, and you'll see, again, reference to X, Y, Z in a bunch of different places throughout AnyLogic. So mobility. And we put together yesterday a fairly sophisticated mobility model, which involved people moving between their homes and the closest clinic to them. We saw how we could ask AnyLogic, tell me the closest one of this set of agents. So we could ask a person when they're just getting set up to ask main for the set of all clinics and ask AnyLogic, tell me the closest one of these set, and use that as my clinic. And we did that. And we had people moving back and forth between that. And that model had unartfully chosen time units. And, going back, I'd revise it today, so I think I've already revised the in-class exercise notes. But the point is that we could capture this kind of movement back and forth over space. And in the afternoon, we expanded on it. We took a basic model and associated with each clinic. Each clinic now had a care process by which care was delivered. And by presenting at the clinic, people would enroll in this care process. They would be taken in by the care process. We'd call the walk-in.take, walk-in with that entry point, and we say, take me into this care process. And they would then proceed, even if they remained an agent in the population with all the full features an agent might have, things like their age and their sex and their ethnicity and their background and their long history from past episodes of care and from their health conditions. Even if they remained in that population in every way, they were also flowing through this process, through this care process. And we put together the most simplified model of a care process, but enough so that we could see how you could request that someone flowing through that care process must be associated with some scarce resource, in that case, healthcare workers, and what that would mean if more than two people presented at the same time. They would be in contention for the same healthcare worker. One might have to wait. One would have to wait, typically. And they could flow through, and they could be delivered care, and upon receipt of that care, it could affect their underlying health condition. We sent them a message that said cured if the care was delivered successfully. And if it was not delivered successfully, they weren't sent this message. And so for some people flowing through their underlying health state became healthy again. Others who weren't in receipt of adequate care simply flowed through, and both groups left the clinic. Moreover, we saw how we could capture balking, that if people waited too long, maybe because there was quite a bit of demand for this healthcare worker, they could leave the facility without securing care. And we saw how that could be done by having that timeout transition associated with the so-called Cs, where they were looking to be associated with that resource. And upon return from that facility, physically moving back, they were also no longer in a care-seeking mode. So we have these different state charts, one for care-seeking behavior and one for behavior associated with health. And that afforded us quite a level of texture when depicting that sort of care context. This is significant because by capturing those together, we can capture things that neither could really do justice to on its own. the care process, for all of its rich depictions of the waiting times and the need for resources and availability of resources and workup of patients and in fact the stage processes by which resources become available. That sort of context can capture all this rich detail about care flow, but there's many things it can't capture. It doesn't capture agent-to-agent interactions. It doesn't capture the way in which agents interact. I shouldn't say that. I should say it captures a very slim subset of agent-to-agent interactions in the form of one agent keeping another waiting. But it doesn't capture things like agents talking to each other, saying, how long have you been waiting? I've been waiting here for 8 hours. And the first agent saying, I'm out of here, man, and leaving the facility. It doesn't capture the fact that agents who have a communicable disease may actually spread it in the facility, or they may acquire nosocomial infection from the facility from each other. It doesn't capture, in and of itself, as we're depicting a single episode of care, it doesn't capture memory from previous episodes of care. The fact that a person may be more likely to present for care if they received good care the past time. More likely to be favorably viewing the prospect of getting care, more likely to come in when their ailment is avoided. But it also doesn't capture the fact that if we confer substandard care, people are more likely to come back soon because their underlying condition hasn't been resolved. And we can capture all those things by coupling it with an agent-based model. Now, let me ask this. Riddle me this. Could we capture those aspects of the care delivery that we saw yesterday? Could we capture that in an agent-based model by itself? Yes, we could. Yes, we can. We could represent the availability of nurses. We could represent queuing in an agent-based model. But I will assure you folks that it would have required a lot more effort and time than we took yesterday. And some of you still might be struggling with it. It would have required a lot of mechanisms, getting a Java priority queue into your model and having to represent the count of healthcare workers available right now, and it required a lot more mechanism. Instead, we can do it quite declaratively with these building blocks, show it visually. We could get all those statistics on how many people balked, how many people are going through this process, how many people were delivered successful care. We can get all that visually through using those predefined operators. So, and this is a general introduction to this issue of hybrid modeling in any logic. The question is, certain of the methods, I introduced very briefly, didn't do it justice, discrete event simulation yesterday. That method is very nice, crisp, transparent, as Kurt would say, sweet for representing certain types of problems. It's just elegant, it's natural for capturing certain types of problems. By contrast, agent-based modeling is natural for representing certain types of problems. And, as we'll see, system dynamics modeling is natural for capturing certain types. And really, with any logic, we have this very admirable ability to be able to use the type of modeling that's most natural for different areas of our problem and spare ourselves a lot of grief, a lot of extra work, a lot of extra delusion, because we may be operating with a model with mistakes in it if it's really complicated. We can spare ourselves a lot of time, effort, mistaken understanding, and really potentially lack of confidence on the part of stakeholders by using the right tool for the job. But there's more than that. There's an additional element which is related but subtly different. By this ability within a same model to carve out the different pieces to be used by the different methods, we further are afforded flexibility flexibility to evolve our model as we see fit over time to fit our growing understanding and needs to represent areas of the model. We may start with a very high-level aggregate model. I often start, as does Jeff in the back, with a high-level system dynamics model of a situation. And then we try to learn from it, and we try to expand pieces of it. And some of those pieces may be expanded using an agent-based model, or some pieces may be expanded using a DES model. The point is that we don't have to, it's not merely that we can choose ahead of time which part we're going to do in which method. That would itself be great. But it's the fact that we can evolve that boundary. We can choose over time, oh, we want to go into a bit more detail for this area. Let's use this method rather than this other method. Oh, our understanding is improving, that it's really resource limited. Let's introduce DES modeling for this portion of the model. We can evolve it over time in a flexible, versatile, and a fashion that befits sort of step-by-step incremental learning. So this is the prospect afforded to us by any logic support for multi-method modeling. And you got a bit of a taste of that yesterday. A brief taste. Today, we will further savor that taste. Okay? We'll be able to build atop that, but also expand our frontiers, ladies and gentlemen. Expand them to look at the third type of modeling, system dynamics modeling. So that was a bit of recap from yesterday. Does anyone have questions on that or comments before I go on and do a very brief tour, again, almost inflicting injustice on it, about what the glimpse of system dynamics so that we can go forward to build some hybrid system dynamics models. And then in a crown jewel, we will see a model that links together all three. Yes, Trent.
You mentioned using maps or GIS.
Yeah.
Can you link those to characteristics of your model? Say you've got an animal that moves in a topography.
Right.
The bitmap, the map that you're using represents elevation changes.
Right.
Can you then link that in regards to disease risk?
Yes, we could. I mean, we'd want to talk, so broadly, yes, absolutely. And it's going to become much easier to do with the version that's going to be released. They're estimating October 15th, but it's 7.1. It's going to make this a lot easier to sort of do geo queries and sort of query what's at a point or what's the nearest, water or what have you, water body. But yes, you can link it into the model. And I'm going to be showing a model this morning. And per elective feedback on the part of people here, you may be building a model this morning that might give a little bit of glimpse related to one way that sort of habitat or what have you might link in with model dynamics. But broadly, absolutely, you can do that. And the only question in my mind is, what's the nature of the functionality of how it's of what you need? In other words, what's the nature of the relationship between that information and the dynamics of the model? Where does it come together with the causal pathways represented? That will be what I've been thinking about. How does it affect things in the model? Through what specific kind of types of mechanisms? And then there's the extra question of the plumbing. And it's the plumbing that's becoming a lot easier in October, likely, or early November, depending how things go. But I think the deeper issue is in exactly what way does it affect the causal pathways, and that will be varying on a situation by specific basis. For example, you could have terrain type affecting rate of movement. You could have terrain type affecting water deficit on the part of an animal. I'm just imagining, an animal walking and in sandy soil with little vegetation being less, maybe needing to go get water sooner than one that's browsing on rich vegetation. Maybe it would affect visibility and therefore grouping behavior or exposure to predation. I can imagine all those sort of interfacing with model sort of causal causal linkages in different ways, but you could capture all of them with the link to the GIS data, I would imagine. Is that helpful? Oh, okay, yes.
I was wondering if you could call out, maybe even as you're going, to the types of questions that you'd be answering with.
Sure, I'll try to do that.
And that would call for different combinations.
Sure, I'll see if I can do that. I appreciate you mentioning that. I tried to do it a little bit yesterday with some of my remarks with the hybrid model yesterday. For example, the ability, by virtue of hybridizing, not simply sticking with the DES model, but hybridizing it with the broader population model, we might be able to better cap, the impact, the longer term impact of an intervention that focuses not only on, as you say, drill and fill, but on behavioral counseling. Because someone could be excused for saying, take sort of a bean counter mentality, a non-systems thinking type mentality is, well, okay, so you're telling me that our clinic is now going to do behavioral counseling. It's not merely going to be, dealing with the patient's immediate health needs. How in the world are we going to be able to support that? It's going to take longer in our process. We're going to need, we're going to have longer periods of time dealing with each patient. We can't afford that. We're already overloaded. And you can imagine someone saying that, and I think there's a reasonable systems thinking response is, well, yes, it's true we're overloaded right now, but we're overloaded because we haven't plugged the hole in the boat. We're so busy bailing we can't plug the hole. We're talking here about plugging the hole. We're talking about dealing with the underlying problem behaviorally. And yes, it will take some time to deal with that underlying problem, but that's going to actually reduce our caseload. That's going to reduce the number of people coming in to this clinic, and we won't be so overloaded after a period of time. And the bean counter could ask, well, how soon is that going to be realized? Okay, maybe we can afford to hire someone for the next 2 years, but beyond that, it's outside of our possibility. And a model like a joint one could be used to show that it would decrease the caseload after a certain period of time and give an estimate of how long, until how long. It could also be used to capture how upstream factors out in the population concerning more population health, how that would drive downstream demand for services. And conversely, how service changes in the facility might affect the health of the population and then representation and so on. Similarly, if you're looking for economies in your process of your clinic or your healthcare facility, you want to be able to capture the fact of how these will affect representation rates. You don't want to save a lot of money at the cost of poor treatment and then people come right back in. And by coupling those, we can very nicely capture both of those. You could also capture through that model, yes, a word of mouth spread, for example, amongst agents in the population about the good care I got at Sunnyside Clinic. Or adverse word of mouth where, quality lapses. Jeff talks about moments of truth. There's this rich literature on moments of truth that, it's often not about just the average care delivery. It's those key moments where you have the opportunity to achieve credibility with the customer or to lose that credibility. Jeff cites the case based on the literature there, I think, of an airline company that's lost your bags. How they respond to that may forever turn you off from that airline company. So I'm going to avoid X for the rest of my life flying on them. It was horrible. Or you may say, these folks really stand by my customers. I'm going to be as loyal as I can. And so these moments of truth. And so it is with healthcare facilities sometimes. People feel, man, I went there and, it was a zoo and I couldn't get care and they were rude to me and I'm going to try to avoid going back if I can. And that could lead to real problems health-wise, Or they could say, well, they're really looking by me. I'll build up relationship of trust with them, and therefore they're more likely to be effective in counseling me behaviorally. And what I'm saying is a model like that, which captures that rich social context outside the facility, can lend that understanding. Similarly, compared to an agent-based model by itself, we can capture the effects downstream of variety of interventions upstream in terms of impact on care delivery and impact by extension on people's health and on cost, right? We can capture the whole cost side within the clinic context as well. So I think there's very clear questions that could be answered by those coupled models. I hope those are helpful comments yesterday, and I'll see if I can weave in some today. Sure. Any other questions related to hybrid models? So, folks, I'm going to need, before we get started today, I'm going to need an indication from you on one thing. So I got up early this morning and worked on creating a new little model that I thought was pretty interesting for many of the groups. I have groups in mind, and I know where there's gaps in our example models, and I went and I filled one this morning. And that gap concerned environmental contamination and movement between different locations, each of which is exhibiting contamination, with endogenous dynamics of contamination. Fancy words. What I mean by that is the environment has its own dynamics associated with die-off of pathogen in the environment and build-up of pathogen when infected people are present or when infected animals are present. And so there's the environment, it has its own dynamics, these different areas of the environment, and these people are circulating, in this case, that are getting infected by that environment, not person to person, but environment to them. Now, we have a choice. This model is, if I may say so, I think it's pretty neat. It's a pretty neat little model, but it would take a bit of time to build it by ourselves. It's easier than yesterday's model, for sure. It's easier than yesterday's hybrid model. It is a hybrid model. It has stocks and flows in it. System dynamics modeling associated with the environmental dynamics. We could either build it together. It will require a little bit of stretching on your part, but you'll get to see some novel things and reinforce some existing things. It involves mobility. It involves state charts. It involves messages. It involves multiple types of agents. You get to see that again. You'd see some new things. You'll see system dynamics built into each agent. You'll see how you can capture different aspects of environmental context that may be relevant. You'll see how you can make the color of something change in a continuous fashion as to how much pathogen there is in that environment. So it'll change more and more red the worse the pathogen contamination is, and you'll see whiter and whiter the less contamination there is. But it will involve you putting in place two things that I wanted to teach you about, but will stretch you a little bit, and it's a thing called a function. So how many people would be interested in building this model together? As they'd say in Australia, the eyes have it. So we will build it together. Now, I'm going to ask for your pardon because I haven't had a chance to write it down, so I'm going to have to do it from memory, okay? And I'll occasionally have to peek at my model just to make sure what I put in for parameter value. But I'm really excited by this model. I think it's really an interesting model, okay? But first, we're going to build another type of hybrid model together involving system dynamics and agent-based modeling. But to lay the groundwork for that, to establish a conceptual framework, ladies and gentlemen, I'm going to spend a few minutes talking about system dynamics, as I did yesterday about discrete event modeling, just to kind of orient you as to what we're talking about when we're building these stocks and these flows. Okay, so I'm going to